Hi, Alan here. Today is May 25th. I'm here with another video lecture. I'm now starting Module 2. I'm finishing up Chapter 2 first. And this is where we left off the other day. We were talking about annuities, okay? Once again, we have 4 tables. The first 2 tables, A and B, are for a single amount, one investment only, okay? We have a shortcut provided by tables C and D, or 3 and 4 if you wish. And rather than using tables 1 and 2 over and over and over again for a stream of payments, we can use a shortcut if the payments always stay the same. We can use tables C and D as annuities and do one mathematical operation instead of many of them, okay? When we finished off the other day, I was on page 30 and I demonstrated present values of ordinary annuities, and I indicated that one common application is to say, if I'm offered a choice between a stream of payments, like when you win a lottery, or accepting a cash lump sum instead, which will be significantly smaller, which should I take based only on the numbers? Forget about all other non-numeric factors, okay? Like we're going to ignore taxes, personal preferences, your concern about the liquidity of the state, that type of thing, okay? We're going to base it only on the numbers. Okay, so if the state offers you $1.4 million, I made these numbers up, 20 annual payments of $70,000 starting a year from now, or they say instead, we'll give you cash of $750,000 today. What do? Which one do you take? You cannot answer that based on numbers because time separates them. You can't compare 750 today to 1.4 million received in the future. You must factor in the time value of money. So, I demonstrated to you that if you take 20 payments starting a year from now of $70,000 and you discount them at 7%, I just made all these numbers up, okay? I'm going to go to table 4 and look up my factor, and I find that 7% for 20 years, the number is 10.594. If you multiply one single payment, a $70,000 annual payment, times that number, the present value of all those $70,000 payments for 20 years comes to $741,580. You would take that number and compare that number, present value, to the $750,000 in cash. Present value. You're comparing apples to apples. And you take the bigger of the two numbers. Okay? You would take the $750 in cash. It's bigger. Okay, now what I'd like to do is I'd like to give you another example. Okay, and I've got an Excel spreadsheet here that I will post for you along with this video. We're going to do the whole thing again, but this time we're going to assume that you don't earn 7%. You earn 6% on your money, and I'll talk more about where we get these interest rates in a little bit. Okay, if that is what you earn, you're going to use that to discount all your future cash flows instead of 7%. So, and I put a thought in here. By discounting using a lower rate, you get a higher present value. Why higher? Well, it makes sense. Because if your money isn't working quite as hard, your money's only working at 6% instead of 7%, then to grow to a known future value, you've got to start with more. Okay? The greater your interest rate, the less you can start with because your money works harder for you. This is the opposite. Your rate is lower, so you need to start with more to get to that amount in the future. So I spelled all that out for you. Okay? You'll have to scroll a bit for it. And I'm going to do another problem. Same choices. Either take $750 in cash today or 20 payments of $70,000 starting a year from now. All the facts are the same. The only thing is, this time we're going to go to the tables and find out what's in the 6% column, not the 7% column. Okay. Make sure you've got the right table. This is table D, present value of an ordinary annuity. We're going to use 6% this time. Okay, so we're going to go down to 20 years. That's going to be on line 26. Okay, the 6% number is 11.4699. Okay, we're going to multiply that number times one $70,000 payment. Don't use 1.4 million now. You only use one payment. Refer back to the formulas in the slideshow and in my text, okay? Math it out, and we get 11.4699. This time, the present value of all of those future cash payments, I'm sorry, all of those future $70,000 payments, please forgive me, is $802,893. Okay? That's the, and I'll put that, that's the present value, the PV, of the future payments. And I told you that 750 is the amount of a cash lump sum. So this time, you take the payments, not the cash. Okay? I hope that you'll find that helpful. Okay, that's where we left off the other day, but now with another example that I hope you will study for me. Let's go on. Next in the book, now we're moving on to page 31 and beyond. What interest rate do we use? Okay? Well, number one, you've got it easy in this course because I'm going to give it to you. In real life, you would use what's most appropriate for the circumstances. The rates that they give you. Sometimes you know the interest rate, all right? It's given to you. The rate that history shows you can earn, okay? If I can reliably make 11% on my money, then if I look at alternatives and I want to discount them today, I know that I will use 11%, okay? History shows that that's what I can comfortably make on my money. So if you give me money, I'm going to invest it, make 11%, that's my alternative interest rate that I would use. Number three, it could be the rate that you can borrow. Suppose you're doing a project for your boss and you have to discount something for the company to find out whether the company should spend the money or not. That will be the subject of something we study in the future. What interest rate do you use? Well, in that case, you'd probably pick up the phone and call the corporate treasurer and say to her, if I go out and borrow money for this project, what interest rate will the bank charge me? And she'll give you a rate, and that's the rate you would use. Okay? You can use comps. If you're into real estate, you know that the value of your house sometimes is going to be based on comparable sales that happen around you. So what's the answer? There is no answer. You have to use the interest rate that's specifically right for your situation. That's a real life scenario. Again, here in the class, in the book, in quizzes, in the homework, you're going to be given an interest rate to use. This is where they really come from. All right. So now we have talked about ordinary annuities in tables C and D, the two examples I gave you, future value going forward and present value coming back. Ordinary annuities means nothing happens until 1 year from now. If you're receiving money like that lottery, you don't get the first payment until a year from now. If you're doing future value and investing a regular amount year after year, you don't make the first payment until a year from now. Sometimes that just doesn't make sense. Okay? If you win a lottery, you might expect the first payment right away. If you're making an investment, putting money away, it makes more sense to start by making your first payment now, not a year from now. So tables C and D are useful to us as far as doing calculations, but sometimes they're not practical if you're going to start your cash streams immediately. If you do, it's not an ordinary annuity. It's called an annuity due, as you can see. Okay? An annuity due, it means it's just like an ordinary annuity, except you're going to make the first action, whether it's compounding or discounting, happen today, not 1 year from now. Okay? All right. So even though the tables are based on ordinary annuities, and by the way, we always assume in my class that annuities are ordinary unless I specifically tell you. Okay? I'll make it very, very clear. So that means we're going to start today. Well, it doesn't mean that we have to go out and get 2 more new tables. They do have tables for them, but rather than burden you with more tables to confuse and accidentally look up the wrong number on, instead what we do is we do one little tweak, and it's a simple one. Some textbooks make it 2 steps. I do it in 1. We go to table C and D, and if it's an annuity due, rather than an ordinary annuity, we do one little piece of surgery on the factor from the table before we use it. Okay? Okay. What we do is we are going to we're going to take a problem that's based on an annuity due. We're going to assume, just for a second, that it's based on an ordinary annuity, and we're going to go to the appropriate table, C or D, 3 or 4. Okay? And you're going to look up the number, the right column, the right row, and grab that factor. But before you use it, before you apply it, you're going to do one little thing to it. You're going to multiply it by one additional compounding period. What is that? It's that magical number, 1 plus I. The magical number is 1 plus I to the nth power, but because it's one extra period, n is 1, you can ignore the exponent, okay? Because anything to the first power is the thing itself. So you're going to say, if this were an ordinary annuity, I'd go and grab this number from table C or D. But because this is an annuity due, I'm going to take that number, I'm going to multiply that factor by one additional period, 1 plus the interest rate, and that is the new and improved factor that I will use to do the rest of the math in this problem. Okay? All right. The best way to learn how to use these things is by an example. Now, several slides ago, friends, I demonstrated the future value of an ordinary annuity. And we said, what happens if I put $8,500 a year away, starting 1 year from now, ordinary. I'm going to do that for 5 years, 5 payments of $8,500 at 7%. Okay? I walked you through that, and we determined back on page 28 that that number was about $48,881. Okay? That's what those 5 payments of $8,500 would grow to, plus interest, including the interest, I should say. Okay? It's going to be $48,881. Now, if this were an annuity due, that would mean we'd make the first $8,500 payment right now. We're not going to wait for a year. It means that we're going to get a lower or a higher number. Which? Well, if you're putting your money to work at 7% right away instead of waiting for a year, doesn't it stand to reason that you're going to end up with more? So the future value of an annuity due should be greater than what you get for an ordinary annuity. Your money is starting to chug for you immediately. Okay? And you're not wasting your last payment either. Because if you recall, our last $8,500 payment before went in on the last day of the final year. It didn't have a chance to earn any interest. So you got stiffed in the first year, and you didn't make money in the last year either by using an ordinary annuity. So we're going to end up with a lot more money by doing an annuity due. Let's see. Okay, now when we did the problem before, friends, we went to table C, 7% column, 5th row, and the factor was, I hope you'll recall, 5.7507. Scroll back several slides if you would. I give you a copy of the slideshow and refresh yourself on the math. Okay? Or go back to page 28, I think it was on. So what we're going to do is we're going to use the same number, 5.7507, but if I tell you this is an annuity due, you're going to take that factor, that's an FVIF sub A, as you'll recall from my formulas. You're going to multiply it by one more period, 1 plus I, so that would be 1.07. Your new and improved factor is 6.1533. Okay. Now, finish out your problem, solve the problem, just like we did before, using the new number. 8,500 times 6.1533 gives you 52,303, not 48,881 like before. We end up with more money because our money went to work for us. Here's a proof that I laid out for you. Excuse me. This is the 3rd video I'm recording for you wonderful folks today, so my voice is running on empty. All right. You'll remember we started with 0 in year 1 before. We didn't put the money in until the end of the first year, so we had 0 interest. This time, our money in year 1 is going to work for us, $8,500, and the first year's interest is accruing as we go. By the end of the year, therefore, we have $9,095. Then, on the first day of the second year, we put in $8,500, the second amount. So $9,095 that we ended last year with, plus $8,500 starting year 2, we generate a lot more interest, $1,231.65. So take 9,095, add 8,500, add 1,231.65, and now at the end of year 2, you've got 18,826. Do it again, okay? And you see that you end up with 52,302. as opposed to 48,881 like when this was an ordinary annuity. Study this very carefully for me, friends. Review the slideshow, review my video, and of course, review the book. Okay? All right. Now, does it work coming the other way? Yes, it does. You're going to do exactly the same thing if you're discounting, if you're coming from the future back to today. Okay? So what's going to happen is you're going to take your first payment out immediately. You've got a stream of payments. We used four $50,000 payments at 4% for this annuity. Before we ended up with a present value for an ordinary annuity of $181,495. Okay? Now this time around, we can expect that we're going to have to start with a little bit more. Whether you're going forward into the future or back from the future to the past, compounding or discounting, you have to have a bigger result. In the future, it makes sense because your money's working sooner for you. You end up with more if it's an annuity due. How about if you're coming back to the present? You're going to take the first payment immediately. That means you have to start with a higher present value. It makes sense. Okay? So, either way, you end up with a larger number, whether it's future or present, when an ordinary annuity is instead an annuity due. So you're going to go to Table D, multiply the factor by one extra period, 1 plus I, and that's the factor you use. So before we had four $50,000 payments that we were going to take out of the annuity. We tried to say what is the present value of that annuity today that will accomplish that. So that when we take our fourth payment out, the annuity has done its job, it equals 0. Okay, so we know that we're going to go to find the present value of an ordinary annuity. You go to Table D. You find the factor. Okay, 4 years, 4%. The PVIF was 3.6299, as you recall. This time, what we're going to do is take that factor and multiply it by one additional period. 3.6299 times 1.04, that's 1 plus I, it's 4% interest, gives us a modified PVIFA of 3.7751. Multiply one payment in our stream of payments, $50,000, by that number, and we get 188,755. We're going to take 50,000 out right away, so we need to start with more. And year 4 is going to earn nothing, since the first day of the 4th year is when we take that payment out. So to make it look easier, let's see how that works. Okay, I apologize, there should be a space. Okay, my numbers got a little messed up there, I apologize for that. I'll clean that up before I post this for you folks. But you can see what's happening. Okay, we start with the new higher number for this annuity due, 188,755. We started with 181 before. All right, we take out 50 immediately, so only $138,000 works for us in year 1, but it still earns $5,550 of interest, leaving us at the end of the year 2, 144,305. Okay. We do that again and again. You see that at the end of year 3, we've only got 50,000 left in the annuity. On the first day of year 4, we pull that 50,000 out and the annuity is dead. Okay? So hopefully that helps you understand the difference between an ordinary annuity, I beg your pardon, and an annuity due. Okay, my timer has gone off. I'm going to have to end this lecture at this point. And as always, please make sure you get in touch with me with any questions. I've had some excellent interaction with many of you so far. Never hesitate to write to me with questions. I'll give you as many test problems as you like. Okay? Have yourself a great day, and I'll be back at you soon. Bye-bye.